welcome to today's Tech Talk session on winning in the age of LLMs. Claude can code better than you, now what? Organized by IET on campus, NSBM Green University. The student chapter of IET on campus, NSBM, was initiated in May of 2025 and has since made remarkable progress within its first year. It aspires to empower engineering undergraduates at NSBM Green University while fostering strong connections within its students and the rest of the global industry. And today we hold the fourth session of the Tech Talk series. Engineering is a field of evolution, of technological advancement and constant transformation. This dynamic field is ever expanding, each day bringing the dawn of a new innovation. And right now, we live in an age where any human activity that used to consume copious amounts of our time and effort can simply be generated using AI. 5 years ago today, AI was all but fantasy, and now it has integrated itself into our daily lives. Today's session will explore how large language models have drastically changed the software development landscape. What advantages software engineers hold in the present job market, and how to take advantage of the opportunities unlocked by LLMs, allowing fresh graduates to reach their full potential in the industry. Joining us today is our speaker, Mr. Nuwan Samarasekera. He is an alumni of the University of Moratuwa and National University of Singapore, with over 15 years of experience, including over 8 years in the field of digital payment and infrastructure. He now serves as the founder and CEO of TestChimp, a novel dev tool solution leveraging AI in the QA domain to fast-track testing in software teams. Followed by today's presentation will be a Q&A session where you can ask questions and directly interact with Mr. Nuwan Samarasekera to gain clarity or answers to any questions that you might have. So, over to you.
Awesome. Thanks a lot, Hitachi, for the introduction and setting the context for today's event. Let me try to share the slides as well. Can you all see the slides?
Yes, sir.
Awesome. I'm not very familiar with Microsoft Teams, so I'm trying to figure out. It doesn't show for me, but okay, you guys can see it, right? So then it's fine. Yeah, so so today what I wanted to talk about was like, so when Hitachi reached out for a tech talk and suggested a topic, I said, let's go with this one, because we're living in a very unprecedented sort of time in the industry, where probably the biggest disruption to have happen in the industry is happening right now, which is LLMs being able to code and do so many other things as well. So yeah, so while the topic says Claude can code, but it's basically trying to say, like, LLMs in general have sort of overtaken our capability to code. And what does it mean to everybody in the software industry? Are we doomed? Is it great news? Is it bad news? So that's sort of the context. A quick introduction to myself. As Hitachi mentioned, I'm an alumni of University of Moratuwa, and then I did my master's in the NUS in Singapore. And after that, I joined Google over there in Singapore, where I spent 8 years. Primarily in Google Pay. It was called TES back then. We were launching a new product for India, and we grew it from 0 users to 200 million monthly active users, and then it became the Google Pay for the rest of the world as well. So in 2024, late 2024, I quit Google to start my own startup called TestChimp, which is in the domain of QA. It's a dev tools solution that utilizes AI and LLMs to facilitate better QA. I will go into more detail as to why that specific domain, the reasons behind picking that as well. as it relates to today's topic. So I have been working in large corporations as well as building my own company as well. So in today's discussion, I will be looking into both of those angles and what it means to be an employee and how it impacts, and what it means to be building in today's tech landscape. And yeah, so I hope we'll have a longer Q&A session. So I'll try to like finish it off like 45 minutes or so, so that we can, I'm really excited to talk to the fresh batch because you guys are in an interesting time. So the reason why I said that was as I mentioned, like we're in a very unprecedented sort of disruption period where before that, coding skills and language proficiency was the core competence. So you would have gone through like OOP classes and Java, learning Java and security and all kinds of subjects. And what happened was that all of a sudden that became stable stakes. Now everybody can code. So it's if you think about like this specific sort of fresh graduates of today, of last year, they are in a very interesting sort of place, because if you think about the batches ahead of you, they learned in like similar to me. So they learned in the old world of how the technical industry ran. So they learned for that, and then they got jobs in that old world, and then they were able to climb up that ladder using coding skills as a core competence. And if you think about your juniors who's currently doing O-levels and A-levels, by the time they reach university, the education system, like the tech curriculum, would have adapted to the new reality, which is like LLM based and like AI workforce and so on. And so they will be learning in the new world environment, and then they'll be going into the jobs in the new environment. But you guys are in this very interesting period where you learned in the old system, and now we're getting into the new system. It's almost like you spent 4 years learning how to ride horses, and then all of a sudden cars got invented, and you're like, well, what now? So that's a very interesting point to be in, but it's understandably could be quite anxiety driving as well. But there is a lot of pros, which I will go into detail in the next slides. So the reality is like LLM models have been becoming better at reasoning at quite an unprecedented rate. And this has changed how we operate in the tech industry. So this is an example. Like when I started working, Stack Overflow was like daily, hourly visited site, because whenever we get an issue, we would just check Stack Overflow. That was the number one place we would always go to. And there was so you would if the question was not present, then you would ask the question, and then people would comment, take ages to comment, and then so it's a lot of back and forth, and then you will try out some solution, and almost always you don't find the exact question that you had. It's like you may ask like, how do I do it in Java, but with Spring, but there's a solution which is using Juice or some other solution. So you had like adopt that answer into your solution. So it wasn't like a direct reusable answer as well. So there's a lot of retrofitting that you had to do, taking that in. But now I don't know whether this you guys have ever even like heard of Stack Overflow or you used Stack Overflow. But from the graph, it seems like it's kind of dead right now, because there's no reason to like go into like Stack Overflow and ask questions, or search there. You can just ask ChatGPT. And if you think about like how quickly things are changing, I remember like back in 2024, that's when I quit my job, and because I was seeing this LLMs coming up, and I remember like very clearly, there was one day when so there was an internal sort of Google research thing that was going on, and they released that internally. What it did was mind blowing, in that I still remember like the interface had like you could explain in plain English whatever image you want, and we would like throw crazy shit like, you know, a frog riding a rocket over the moon or whatever, and it would like spit out this image, and we were like mind blown by what was made possible. And surprisingly, Google did not release that back then. And understandably, the reason was because there were like so many concerns around like what kind of images would people create, and like, you know, how, all those ethical questions that was coming up. And then OpenAI sort of jumped the gun, and then they announced there's this new technology, and then, you know, the rest is history. But that was 2024, when that was like a miraculous, surprising thing that we kept under covers, being able to like go from a prompt to an image. But I'm guessing like, you know, this does not surprise any of you. This is like table stakes now. But even in 2024, the LLMs were fairly stupid, I would say. Like, you know, if you were to like use it for like coding, it would almost always like have no reusability. It would have like output spaghetti code. It was not a human replacement sort of a entity. And so if you look at this graph, like in 2024, late 2024, the GPT-4o was like, so this is an AI performance solving issues from Python repositories. A SWE benchmark, which is a fairly famous standardization sort of a benchmark. It was at 30% compared to a human. And if you go over here right now, it has gone in the space of like 1.5 years above 80%. So gone from 30% to 80%. And of course, the earlier jumps are much larger because there was a lot of room for improvement. But even then, even after we hit like 70%, we still keep on improving. And interestingly, what's interesting is like Claude Opus 4.5 no thinking still gets close to like 80%. It feels like an unnecessary like jab at saying like even without thinking too much, LLMs are doing pretty well. So I remember like back when in 2024, people were very, very skeptical about like, is this even a threat at all? Because I don't know how much you're familiar with LLMs, but LLMs are basically how they operate is they predict the next token for the most part. And we had that technology for ages, like, and that's how in emails you had like autocomplete. If you type a sentence, you would get a few more words suggested. And it's literally that same technology that was sort of expanded onto we started off with like transformers by DeepMind, and then that sort of expanded onto LLMs. And it's still underlying that is the philosophy of LLMs. But then, you know, it got significantly better over time at a rate where nobody saw this happening. So the point I was trying to say was like, we probably need to like be cognizant about the fact that there's a lot of uncertainty going forward, as well as like how quickly things would develop. Like, so for instance, Sam Altman was saying AGI would be like achievable by like 2030. So AGI is like, it's called artificial general intelligence, which is like the ultimate goal, which is fairly equivalent to human-ish kind of a AI level. And now people are saying that that is not, that's a pipe dream. But that's what we said in 2024. That's what we said in 2025 about the things that is happening now. Yeah, so that's something to think about. Now, having said all of that, so the big question now is that is software engineering doomed? So given this, LLMs can do so much of what we used to do. What's the role of a software engineer? And you may have heard, like, there were huge layoffs happening in every single large company, 10,000, 20,000, 40,000 people getting laid off across all of the big tech, all of the companies like Airbnb, Spotify, and so on as well. And primarily because of like AI saying we don't need this many people to do the task we were doing. But an interesting thing about this is this idea called Jevons paradox. I don't know how many of you are familiar with it, but the idea is that so there was this guy called Jevons back in 1800s, and he observed an interesting point, which is it was around that time when the steam engine was invented, and which is basically like a much more efficient way of burning coal and converting it into energy. And what you would assume to happen is that now that coal can be converted to energy in a much more efficient way, you would need less coal because you get a higher amount of energy from the same amount of coal. So the demand for coal should drop and the price of coal should drop as well. But what happened in reality was that the demand for energy increased significantly because now energy became a much less costly thing to produce. So energy was used in areas where they were not being used, in ways it was not used. So basically the top of the line overall demand for energy became so much significantly larger that the demand for coal itself went up as well. So this is the paradox, essentially, where the more efficient resource becomes, the larger the demand it ends up getting. So it's almost like if you, yeah, it's kind of like, you know, now you can do a lot more, and so a human nature is that we would like not try to do what we were doing earlier on, but try to expand to do more stuff. So the argument would have worked that if the coal consumption remained the same. So for instance, if energy was used to doing the same work that was being done before the steam engine, then yes, coal demand would have dropped. But what happens is the implemented areas increase, so that the demand increases for coal. So how that relates to engineering is that now we're actually seeing the latest graphs are showing that the number of job postings are actually increasing for software engineering, which is good news for you guys, I assume. Yeah, so it's basically, it's almost always that's the pattern where you have an initial dip because at that point the output is what we knew could be done was this X amount of work, and now you have this thing that can do that very quickly, so you don't need these people to do all of those tasks. But now what happens is if you look at software engineering today, we are producing so much more software than we used to do 2 years ago. People are building like end-to-end applications over a weekend, which was simply a dream back then. And this is not like a linear improvement, by the way. So I myself, I personally, I'm a big fan of Cursor, and I would say running my company, I run it as a solo entrepreneur, I developed the whole thing. And if I were to build the same thing today without Cursor or Claude, it would have taken like 7, 8 engineers, senior engineers, sort of a team. And even then, you would have had like, months of work. I've seen like easily months of work be shrunk down for like a weekend. If you take into account like going back and forth with Stack Overflow and finding answers and retrofitting and all of that. But that is not to say that the emergent jobs and the emergent roles are the same as what they used to be. So that is, I think, a place where people really get tripped up in that they think, okay, now Cursor or Claude, it can code. So there's no point of having software engineers. And that's not true. There's demand increasing. There's a lot more demand for like software engineers now. But that is not to do the same role that we used to do as software engineers. So the job of writing boilerplate code for interacting with databases or writing scaffolds for like API endpoints, services, whatever, all of those very easy tasks that we used to spend a lot of time doing, that job is gone. That job is dead. That job is never coming back. That job is a prompt away for anybody who can speak any language, essentially, for them to like type it out and get it out done. So basically, what happens is that it's a whole new type of roles that come out. And here, so for anyone who's not familiar with Andrea Karpathy, Andrea Karpathy is one of the leaders of technical industry. He's the head of AI. He's head of AI at Tesla. And I think he was part of like the founding team of OpenAI as well, if I'm not mistaken. A huge name in the tech industry. And he recently tweeted saying like, I've never felt this much behind as a programmer. The profession is being dramatically refactored and so on. So he's saying like he cannot keep up with all of the things that is happening from involving agents and sub-agents and prompts and context, memory, modes, permissions, tools, plugin skills, hooks, MCP, LSP, slash commands. All of those things are like so many things happening. And to be honest, when I saw this, it really related to me because I also feel the same way. And I think everyone who is in the industry feels this exact thing, but they don't realize that everybody else is also feeling the same thing. Like everybody's assuming that others are totally understanding like how, like keeping up with all of those updates that is happening. Like one day MCP comes up and then MCP is like king. And then the next day somebody's like, MCP is dead. MCP is not the way to go. CLI is the way to go. So there's like a lot of churn in terms of like what is the right thing. And for a very short period of time, there was this idea called prompt engineers will be the new engineering role. And because for that short period, what happened was like if you don't prompt it precisely, the LLM would not produce our output optimally. But then what happened was that the LLMs became much smarter, that it could like take a simpler prompt and actually deliver high quality work. So prompt engineering also sort of like died within like a few months of time. So yeah, so the point I wanted to make was like, if you feel like you're being like, it is a lot to take in today's world. It is the case for like Andrea Karpathy as well. So don't be discouraged by that. And the second part of that is like the honest answer as to like what roles are going to be. When I said like, okay, it's not going to be the same role. The honest answer is nobody knows. But having said that, we do see some patterns of consolidation. So I talk with, so in my today's role in doing a startup, I speak with potential clients all the time, and I see how their teams are changing in structure and how they think versus how they used to think. And a common theme I'm seeing is that roles are merging. So before all this, it was very, very siloed, separate responsibilities. There was a PM, there was a BA, there was a QA, there was a dev. The dev writes the code and hands it to QAs, and then they do the testing. The PMs decide what gets built, and the BAs flesh out the requirements and writes the user stories and scenarios and all of that. So there was like this whole handoff of activities that happened. On that note, so this was for anybody who's not familiar with Linear. So Linear is so there's Jira, which is a very old solution which people used to use for like issue tracking. But nowadays, Linear is one of the leading companies that is taking on that. In fact, like of Y Combinator startups, 65% are on Linear instead of Jira. And Linear recently, like just last month, they completely changed their entire philosophy of the company, and they put out this statement saying issue tracking is dead. So you can see it's 24th of March. They put this blog post. And the reason why they said it was exactly for this reason that I'm observing when I'm talking with potential clients as well, because issue tracking was built during a time where there was this handoff model of software development. The PM scopes the work and then hands over to BAs, to engineers, to QAs, and so on. But that handoff thing is no longer happening in the industry. What happens is it's a much quicker cycle of like people deciding this is what we're going to do, and then they just give that to their Claude agent, and it writes out the spec, and then it builds out in like 10 minutes time and outputs the result. So now it's about like context consolidation and like how do you maintain context about your product so that the agent has access to all this information and make sense of it. So what Lean is doing now is they've reframed it so that agents can be native participants of the development workflow. So so lower level roles are vanishing, as I mentioned, which is, I think, somewhat of a concern for like a fresh graduates, because like the work that like we initially did, that's the portion that like LLMs sort of excelled at. But again, as I mentioned, like the roles are vanishing and then new roles are emerging. So it's about like preparing, like figuring out what is that role and building that skill set to take on that. So roles merging, I see a lot of the times I talk with my clients, they don't have QA. They're like, we have developers, we want to get developers to do the QA work as well. So it's basically like the devs are like sort of absorbing other roles as well. Now, what this means is that we went from like software engineers were executing tasks. So they would be like, here's a task, implement a service exposing like these 5 endpoints, which are like CRUD endpoints or whatever. So that was an executing task, and that was the goal. Versus now we are moving from executing tasks to delivering outcomes. So basically, the human is responsible for producing an outcome. So the difference between executing a task and a delivering outcome is that so the task execution itself is delegated to agents. So we no longer write code. Like I'm as I mentioned, I'm developing the entire product, and I don't write a single line of code today. Every single thing is written by Cursor. I write in English the plan. I give it to the agent. Agent runs. It writes the code. I review the code, so it's a feedback loop that I manage. But other than that, the execution happens by the agent. But here's the important thing. So between agents and humans, one of the key differentiators is that humans hold responsibility, versus LLMs don't have any responsibility. So if a production database gets wiped out by an LLM, the LLM does not have a job. Like it's not getting salaried payments. So it has no like fear factor of like, there's no, nothing bad happens to them. It's not alive. So they're not responsible. And humans are responsible. So that is where the delivering outcome happens. So basically, you are the one who's responsible to make sure that the outcome is reliable and it works. So basically, the human role becomes like ensuring the guardrails are there and the checks are in place to ensure that the agents are outputting what was expected of them. And tying back to what I'm building, the reason why I got into building that was exactly because of this reason, because we moved from development being the bottleneck, where we spent a lot of time, like developers were the heroes, and then we spent a lot of time building things because it took a lot of time. But now agents are doing that part quite autonomously. So the responsibility of human becomes like, how do I make sure that what they're building is what was expected and it is reliable and it works. So the human becomes like orchestrating and managing agents to get that expected outcome. So so the key advice over there is like try and make sure that you're very familiar with agentic workflows and how you orchestrate agents to get the expected outcome. All right, so the next section is what I'm more interested in as an angle is this is an incredible opportunity to build. Again, the reason why I quit one of the most comfortable jobs out there. So Google is very famous for like having one of the best environments to work in. But even then, it just feels like such a golden opportunity of a once in a lifetime sort of a thing that happens now. So because it basically democratizes the opportunity for everybody to be a builder. This is very similar to how what happened when the internet came up. And I remember, like, I was a kid, and Professor Mohan Samarasekera of Columbia University, he was in ITN or whatever channel, telling, oh, there's this new thing called the World Wide Web, and we're bringing it to Sri Lanka. And the people of that generation really took that advantage of, like, people who were in that 20s and 30s. They were in that right place at the right time to take up that opportunity. And when a drastic change like that happens, the calculus changes significantly. A good example is that if you look at back in 1990s, if you wanted to buy a book, you had to go to a brick and mortar bookstore, and if you were building in the space of book lending or book selling, it took a lot of capital to do that, because you need to have infrastructure to have brick and mortar shops everywhere, every city. It's hundreds of millions of dollars you have to spend to build a business like that. So big companies like big publishers, they were running the whole industry. But one dude who was like sitting in the basement by the name of Jeff Bezos built a company with none of that, and just the internet, and he could take on all of those big giants, and now Amazon is a $3 trillion company, and that opportunity. So for those who don't know what Amazon was doing back then, Amazon was purely a book company. Basically, you could buy just books online, and they would just deliver that via mail. That was it. And then they expanded it to like becoming an everything store. And why that became possible was because so before that, you need to have brick and mortar shops, and you need to have humongous amount of capital to even enter into the business. But if you're in the right time at the right place, what it means is now that with internet, that sort of democratized everybody's ability to participate in building. Of course, it's not as easy as like with LLMs. It's sort of like the distribution channel became significantly smoother, because you no longer needed those brick and mortar entities to sell. You could just order online and then get stuff online. And what happened with LLMs is very much similar to that. And I would say the industrial revolution, the internet, and then the LLMs, that's how big of a change LLMs made. Now, everybody, if you can think something to build, you can build that over the course of a weekend. Back then, back then, I'm like 3 years ago, you had to hire a huge army of engineers to build. If you have a big idea, you have to have a huge army of engineers to like build it. It'll take like 6 months, 9 months, and then you don't have like opportunity to retry. If this doesn't work out, pivot and try something else. You can't pivot for like 2-3 times until you run out of money to pay the salaries, and then the startup dies. But nowadays, Cursor is like $20, Claude is $20, and you can just build. If it doesn't work out, you pivot and try out something else. It's an amazing opportunity in that sense. And it's a true Wild West because nobody has a 10-year experience in LLMs. So everybody is brand new to this field. It's akin to like when I said like you were learning to ride horses, now cars happened. But the good thing is nobody else were also car drivers. So you have the same amount of driving experience as everybody else. Now, granted, like few people have a little bit more, 2-3 years of experience, but not in the scale of decades, which was the case when we were doing coding by hand. So continuing on the opportunity to build, Sam Altman said like we will see a $1 billion company in our lifetime, and that seems like a far-fetched sort of an idea when you think about that. And that already happened, almost. So one man and his brother actually built a $1.8 billion company that was announced like two months ago. And that's an interesting case study. Well, it's a little different of a product. What they did was like they're selling weight loss pills online. And this is an example of 2 ways in which AI can be used in this era when you're focusing on building. One is you use AI in your products and create a product that was not feasible beforehand. This is what I'm doing right now, which is like using AI. So a lot of, if you look at examples like AI note takers or anything with like AI doing this, AI doing that, that's one angle of building. The other opportunity is that your workflows are now much easier to scale. So you don't need to hire a sales representatives. You don't need to hire back office people. You don't need to hire accountants. All of those roles that you had to hire in order to have a company run, all of those can be agents. So what it means is that now a much leaner sort of team, one person, 2 people, can actually scale up a company significantly than it used to be. So for instance, in this scenario, this company is not an AI product that they're selling, they're selling weight loss pills. But the entire operation is optimized by AI, their sales are done by AI, their marketing is done by AI, they have the feedback loops to identify where the marketing should be spent, and all of that is optimized significantly using AI. So that's the other angle to think about it. Like it doesn't need to be like I need to build something in the software domain to utilize LLMs. So this is related to what the Jevons paradox was as well. And so the idea of boiling the lake, this was coined by Gary Tan. So for those who don't know Gary Tan is the president of Y Combinator now. So Sam Altman, the founder of OpenAI, he was the president of president of YC before Gary Tan, and now Gary Tan runs YC. And he recently put out an essay which I really loved. The idea is it's called boiling the lake. Now, to understand what boiling the lake is, you need to know the old adage, which is don't boil the ocean. So basically the saying is don't boil the ocean, because if you try to boil the ocean, it won't work, because you're trying to solve a lot of things in one go, so nothing happens. But the idea behind the essay was that was great advice for back then, but now with AI, the calculus has changed significantly. That at least lakes are very much boilable. So oceans, he argues even the oceans are boilable, but at least lakes are very much boilable. The reason behind this is that AI sort of compresses the time it takes to do something. So some activities by like 10x, 20x, 100x, and so on. So a good example is if you were to refactor your legacy system into a new Node.js kind of a stack, that used to be 6 months, 10 engineers kind of a project, but now you can have an agent to do that. So the way to think about this is that we were programmed or sort of to think about, okay, if you tell a veteran engineer a task, he will go through that, because we have, so myself, for instance, I've been in the industry for like 15 years. So we had like 15 years of learning of like how much time it takes to do a certain thing. So we even had like, measuring the task size and then saying, okay, this will take X amount of time to do. And we have to do a lot of unlearning now to say, okay, that calculus was for different era. Now the math is different. So in that sense, I think you guys are in a little bit of an advantageous sort of place, because you don't have that learning done to think, okay, given a task, how big this is, if humans were to do that. So when that sort of compresses, when the tasks get compressed, now you can sort of chain those tasks to execute much larger scope of work in one go, which is boiling the lake. So when you're approaching about like building products and so on, you have to be cognizant about that. What it means is that you can now enable workflows that were prohibitively expensive back then when humans were coding. So entirely, like some of the workflows, we were like, okay, that's not feasible because it takes a lot of maintenance cost. Those are now all of a sudden feasible. So what does it mean to execute them? So that is one of the opportunities which you can think about to exploit, because those are all unexploited sort of areas that somebody has to go and see, okay, this workflow, we were doing this thing this way, but now how does it change with AI? But having said that, building in today's era is not all rosy. And I'm saying this as someone who's been building for like 1.5 years now. The reality is that everyone else also has the same advantage that you have, because you'll be like, oh my God, I can build anything with Cursor, but so does everybody else. So the differentiating modes are evaporating. So I'll take a quick note on like what modes is. So a mode is basically how do you what is your defensive differentiator that makes you secured against competition. And entire startups can completely disappear overnight because with the AI improving, entire companies' modes can wipe out. A really good example is 𝐶HG. So 𝐶HG is now famous for being the very first publicly traded company to lose entirety of its valuation due to AI. So 𝐶HG, so as you can see, it was a $15 billion company. Back in COVID, it hit its peak at $115 a share. Now it trades slightly under one. So at this point, when I took the graph, it was like $1. Now it's like less than $1. So it has lost 98, or almost 99% of its valuation, exactly due to AI. Because what Check did was like it did homework tutoring sort of thing. So it helped students with their homework. But now you can ask ChatGPT how to do the homework task, and now all their entire value proposition became free overnight. And so we've seen the same thing happening. It's not a one-off as well. For instance, just last week, Claude released Claude Design, and the Figma share price dropped by 8% overnight, because Claude can now do design, which was Figma's whole thing. So the reason why what I wanted to mention this was one of the pitfalls of going into building. What I see is people are not cognizant about the moats, and they don't have a game plan on like how do we differentiate in a way that is defensible. Because one thing, like back in the day, features, more technical, complex product, basically it's hard to build, is no longer a moat. It used to be a moat. Like it takes a lot of technical skills to build this capability, and it's the thing we often assume is a moat, which isn't the case. Like as an example, there's this open source thing called Slock, which was an open source Slack clone that was built in 14 days with Claude Code. So they completely rebuilt Slack. So Slack it's like Microsoft Teams, but way more famous in a lot of growth stage startups. But yeah, they're surviving for other reasons, which I will get into in the next slide. So moats in the data Mira is very specific, and then you have to be like very strategic about it when you're going into like developing products. This is something you have to think about. So there are a few modes that are still relevant. One is data. So the idea behind this is the more a user uses a product, the better the product is at knowing the person. So this creates a stickiness. So think about it like if you have been conversing with ChatGPT all along, now ChatGPT knows you so well. When you ask the question, it can give a very personalized answer. So now if I go to Gemini or something else, Gemini does not know anything about me, so it'll give a very generic answer. So of course, if I like keep on conversing with it, it can also grow its understanding, but there's a switching cost. So because of the switching cost, I keep on talking with ChatGPT, even if it's like slightly worse than Gemini, let's say, hypothetically. That's the point being like, if your product sort of like becomes better and better for the user, the more the user uses it, that's a data mod. The second is network. So the more users on the platform, the better it gets for everyone else. So Facebook, Twitter. So a good example is Twitter. Like Twitter is one of the most simplest applications out there you can build. Like anybody can build it as an intern project or a weekend side project. Put up a status, and then everybody can follow, and then have a wall of tweets. But it's still the top place to like have that have conversations. And the reason is because the hard part is not building it technically, but it's about like getting users onto the platform. And once you have people on the platform, it's better for everyone. So when you have 1 million people, the 1,000,001th person comes onto the platform because there's 1 million people over there. And now that mode got slightly better, slightly bigger, and it keeps on compounding. And this is why like Facebook, for instance, is a gigantic sort of corporation which like has like, I don't know, 3 billion people or whatever, because it keeps on growing on this viral sort of loop. TikTok, for instance, because everybody's producing stuff on TikTok, so then everybody comes to TikTok. And another one is distribution. These three are not the only ones, but these like very prominent ones that we've seen. So distribution is when you have a unique unfair advantage in distributing. So often this is disadvantages with like larger companies. For instance, Google. When they took a lot of time to like embed AI into their applications, but because everybody was like billions of people were already using it, now when you create a new product, that is distributed much easily. And distribution honestly is the hardest part now, in my opinion, like getting people to know your product and like using that product rather than the technical complexity of the product. On the niche markets, smaller players could have distribution advantages. And another angle is like going open source. We see this happening quite often. Browser use is a good example. So when you have open source, OpenClaw is another good example. So it creates a unfair advantage of distribution because now people contribute to that open source project, and that gets better. And a proprietary one would have a hard time competing with that. So this is a graph of all of the things that you can do with AI. So this was released by Claude. And so this is the theoretical AI coverage is what's shown in green, in blue, and red is what is actually covered today. So you can see there's a huge amount of opportunity that is open up for grabs. And a lot of areas like agriculture, construction, installation repairs, those companies haven't even like gotten any AI penetration at all. And then there's like companies like business and finance, architecture and engineering that has a lot of possibility into AI adoption, but hasn't really gotten the full benefit yet. So what it means is that there is a lot of opportunity to like build in any space that you would have a unfair advantage. And I think that's the other point. Like, you know, if you have like medicine background or something like that, then you have a differentiated advantage over everybody else who's like a generic coder. So you have to think about those as well when thinking about building stuff. Cool. Awesome. So I'll open the floor for some questions. Hidashi, how does it work with the questions? Do I see it on the side or?
Oh, yeah, sometimes they voice it out, sometimes they type it out in the chat box. So guys, if you have more questions, this is the time for you guys to ask them.
All right. I'm guessing there's. Sorry, go ahead. Yeah.
Yeah. So you have experience with working with the Google, right?
Yeah.
Yeah. I want to ask, sir, how was the experience in there, and if someone here is willing to go to the Google, what guidance would you give for those undergraduates?
Yeah. So I guess obviously Google is one of the, as I mentioned, like one of the greatest places to work. They have really different culture, much freer sort of room for like experimentation and so on. Having said that, the LLMs again sort of made the perks a little bit lesser. Like we used to have a lot more perks, and then they sort of cut down a little bit of the perks as well. It's still a great place, I would say. Having said, but then again, working in a large company means that you're constrained by a lot of limitations in terms of like what you can try out. As an example, the thing I mentioned around like when the image generation thing, that Google hands down built the first versions before anyone else, as far as I know. And we had to keep it under covers because releasing, we had to like do a lot of ethical concerns and all sorts of things. and that wouldn't be applicable to like a smaller player trying to like come up with something. So we tend to execute a little slower, as we can see today as well. Like Gemini came significantly later than OpenAI and so on. So it limits a little bit of creative progression of yourself. But yeah, so to apply, I think it's usually what they look for is, so I was an interviewer for like 8 years. And a common thing we've seen is that if you've just done your coursework, that's really not the bar. Even when there was no LLMs and stuff like that, we were looking for people who were creative and like who had the passion essentially. Like if you had like side projects, if your GitHub had like projects that you contributed to and so on, that's a really good signal. Versus if another person is like, I did my final year project and that's pretty much it. That doesn't show you have a passion for programming. So that's a bit of a bad sign. So having that profile built is one thing, and the second thing is, of course, there's like a little bit of luck involved as well. So I applied actually 3 times. 2 times I failed, and then the 3rd time I went through. So it's a little bit of a hit and miss as well. But other than that, I think the structure hasn't changed that much. It's 4 coding rounds and 1 system design. I'm guessing now things might have shifted a bit. I'm not up to date because I've been out of it for like 1.5 years. But usually it's like algorithms, data structures, and that's the core of it. Yeah, hope that answered the question.
Yes, sir. Thank you, sir.
Cool. Any last questions?
Okay, sir. This question regarding from AI and human advantage. So, if AI can code perfectly, what unique qualities should human developers focus on? Stay irreplaceable.
Sorry, if I understand the question, so the question is like if AI can code perfectly, then what is the point of like testing? Is that correct?
Yeah.
So I think the reason is like LLMs keep on improving, but there's like a structural limitation, which is that it is at the end of the day a non-deterministic system. So it's not like it can like it's a fundamental piece of LLMs. Like LLMs are built to be non-deterministic, and that's actually a feature. That's how they become creative, and they like if you prompt the same thing, it will answer 2 different things. It will not output exacting like a code would. So what this means is that the non-determinism is something that will not go away, and that is why it can actually emulate a human as well, because humans are also non-deterministic and creative and all of that. So the byproduct of that is that hypothetical situation of like if AI can code perfectly is a bit of a unrealistic one. That's point 1. And the point 2 is even if it was perfect for like 99% of the time, if it fails 1% of the time, the problem becomes who is responsible, because the LLM is not going to lose a job because the LLM does not have a job. It does not get paid. It does not have a mortgage to pay. So it has no implications whatsoever. So so it's you ask it to do something, it does something. That's it. So that is where the guardrails sort of help, because if you have the guardrails set up, then you can let the LLM go crazy and like do whatever it wants, go creative and like output whatever they want, because your guardrails are there to ensure that whatever it does not break production and it does not break the user experiences. So you that's where like the setting up the testing infrastructure matters, so that you allow you enable the agent to have that autonomy. Because if you don't have that, what happens is the agent goes autonomously then do whatever it wants, and sometimes it deletes the production database. And this has happened more than once by many, like Devin used to do that. So Devin is a software engineer AI. And yeah, so this is one of the biggest challenges that we're seeing. And this is the reason why I'm like heavily invested in this domain is because it's the non-determinism is a structural feature of LLMs. I hope I answered that question.
Yeah, thank you very much.
Cool. So I think we are on time as well. In case there's any questions, I'll keep the floor open for like 1 minute probably. All right. So yeah, okay. So since we're on time as well, so I want to leave it with one last thought, which is so this is again from the same essay, the Boiling the Lake essay. I highly recommend to like read it out by Gary Tan, and he was saying that so there's this future. The idea is that you can read it. So our fear of the future is directly proportional to how small our ambitions are. So we have two crowds which are like feared, like people who are afraid of what's happening and people who are like really optimistic. And if your plan is to keep doing what you were doing, AI is terrifying because AI can now do what you used to be doing. But if your plan is to build something dramatically bigger, it's the best news you've ever gotten. So yeah, so thanks a lot, Hitachi and the team for inviting me, and I hope you got value out of the conversation we had, and all the best for your future endeavors. Over to you, Hitachi.
Thank you, sir. Before we wrap up, there is one more question in the chat. It says, with the rapid growth of LLMs, what skills do you think software engineering undergraduates should focus on the most?
Yeah, I guess as I mentioned, it's a tough question in the sense that we don't know. Like we thought prompt engineering was the case, but it proved to be not the case. So we're all trying to figure that out essentially. But having said that, as I mentioned, what we're seeing is merging of roles. So you can no longer be just a developer, like take a spec and then output that, because that's what Cursor can do. It's more about like orchestrating agents to delivering a larger output and making sure that it is verifiable. It is properly, you have established the guardrails and basically being responsible for delivering the outcome versus executing tasks. So I would say like, play with agents, see how they work, see how you can orchestrate them, and basically executing, like delivering outcomes, and scope. It includes like scoping out work, thinking of edge cases where things can go wrong, all of those things where AI is probably, or AI wouldn't care, and you would have to like put the human intuition into thinking through that. And at the end of the day, the software is built for human consumption. So that's where the other angle is, like you as a human know what the humans would want. So that plays into like defining the goals for the agent. So yeah, so it's basically like orchestrating agents and putting that human intuition into getting an outcome that is that makes sense for humans.
Right.
Yeah.
Thank you, sir. And
Cool.
thank you for your truly exceptional session, which I'm certain provided all of our attendees with unparalleled insights, along with a newer perspective into engineering in software and how it has evolved over the decades. I would also like to thank you for taking the time to share your immensely valuable knowledge and experience with us today, which I believe proved extremely worthwhile to myself, I'm sure, and all our attendees. And thank you everyone for joining in for today's Tech Talk, Winning in the Age of LLMs, Claude can code better than you, now what? With our speaker, Mr. Nuwan Samarasekera. To deliver the concluding remarks, I would now like to hand the session over to the Secretary of IET on Campus, NSBM Green University, Tharika Gajaria.
Good evening, everyone. On behalf of IET on Campus NSBM, it is my pleasure to deliver the vote of thanks for today's session. First of all, I would like to sincerely thank Mr. Nuwan Samarasekera for sharing his valuable knowledge and experience with us. Sir, your session on winning in the age of LLMs helps us understand how AI is changing the future and how we can prepare for it. We truly appreciate your time and effort in guiding us. Your insights were very useful and inspiring for all of us. I would also like to thank our organizing committee, executive members, and volunteers for their hard work in making this event a success. A special thank you to all the participants for joining and actively engaging in today's session. We are also grateful to NSBM Green University for their continuous support. Finally, thank you everyone for joining us through Microsoft Teams and making this session meaningful. Once again, thank you, sir, and thank you all. Have a great evening.
See you guys. Bye.